Hello friends, now let's see another problem. A square prism penetrated by vertical cylinder. So vertical cylinder of 70 mm diameter and height 100 mm is completely penetrated by a horizontal square prism, side 50 mm and length 110 millimeter. The axis of the prism bisects the axis of the cylinder. All the rectangular faces of prism are equally inclined to HP. Draw front view, top view and side view showing the curves of intersection. So in this problem, there is a vertical cylinder, base diameter 70 mm and height 100 mm. And it is penetrated by a horizontal square prism, axis of which is parallel to HP, and the faces of the horizontal prism is equally inclined to HP or VP, and axis of the cylinder is bisecting by the axis of the square prism. So first we will draw the vertical cylinder. So this reference line, vertical cylinder XY, X dash Y dash. So vertical cylinder, top view will be circle, front view will be rectangle, side view will be rectangle. So top view of diameter is 70, means radius 35. So this top view, diameter 70, and we are dividing vertical cylinder into 4 number of parts. So this A, B, C and D. Then in front view, it will looks like a rectangle. Height is given to us, that is 100, and diameter is 70, means 35 mm left side of the central line and right side of the central line. So this vertical prism, a vertical cylinder, and this vertical cylinder. So this will be A dash, this will be B dash, D dash, and this will be C dash. Similarly in side view, for side view 45 degree, is 45 degree, and this axis of the cylinder is to be projected, and diameter is again 70, means 35 mm left side, 35 mm right side. Height will be projected from the front, and this will be the side view of cylinder. So this D double dash, this will be A double dash, C double dash, this will be B double dash. This is the problem number 42 from TechMax book. So vertical cylinder is penetrated by horizontal square prism, base 50 mm side and axis 110 mm, and faces of the square prism is equally inclined to HP, and axis of the prism is bisecting the axis of the vertical cylinder. So bisection points, so this 100 half is 50, so this 50, and equally inclined to HP means 45 degree, 50, so this 50 is to be adjusted here, 50, 50, 50. This problem is, I think, wrong. diameter is 70. So horizontal prism size I am taking 40. Something wrong in this problem. So horizontal square prism base 40 mm side and everything is the same, means equally inclined to VP or HP and axis bisecting, etc., etc. So size, here I am changing the size. Instead of 50 I am taking 40. So this 1, 2, 3, 4 double dashes because it is side view. So this is top view, front view and left hand side view on the right hand side of the front view. Now project this in front view. So length is given to you 110, so 55 mm on the left hand side and 55 mm on the right hand side of the axis of the vertical cylinder. So this will be like this. So front view, which is incompleted one. So this 2 dash 1 dash 3 dash and this 4 dash. Now project it in top view. So length will be projected from front and width will be projected from side. So this what prism penetrated and comes out, and here longer edge penetrated, invisible inside the cylinder and comes out, and side 3 will be here, penetrate and comes out. So this will be the penetrating prism. So this 3, this 2, 4 and this 1. So side view is completed one, top view is completed one, incomplete view is front view. So intersection curve will be in front view. Now locate the intersection points. As we know that left hand side P, so this P3, this longer edge P2 and P4 intersecting, this longer edge P1 intersecting, and right hand side Q1, this Q2, Q4 and this Q3. Now you are seeing from this side and this side. So we will start from 3. So P3. So this P3. So project this P3. P3 is intersecting to longer edge 3. So this P3. P3 will join to P4. P3 will join to P2. So project this P2 and this P4. Now here there is a problem. The curve either like this or like this, we don't know. So in such cases, or whenever the prism penetrates to the cylinder, you have to take the extra points. Extra points means this is the 4 point. So I am taking the midpoint of 40 means 20. And this 20, 20, 20 project. So this is 5, this is 6, this is 7, and here this is 8. Now project this 5, 6. So this 5, 6. So this 5 and 6. Similarly, project this 7, 8. So 7, 8. So this 7 and 8. Similarly, project it in front view. So this 5, 8 longer edge, extra longer edge, and this 6, 7, that is extra longer edge. Again, locate the intersection point. So this P7, P8, and this P6 and P5. Again 3. Now 3 will join to 8 and 3 will join to 7. So project this P3 and P8 and P7. So this P8 here and P7 here. So this P8 and this P7. Join this point with the help of French curve like this. Okay. So what we have done actually, there is a 4 penetration point or intersection point. With this 4 intersection point, curve is not obtained properly, so I have taken 4 another extra points. Now 2 will join to 6 P6. So project this P6 here, it will be overlapping, and here P4 will join to P5, this P5, and P5 will join to P1, P6 will join to P1. So front intersection curve overlap backside intersection curve. Similarly on the right hand side, same procedure. So we start from Q3. So this Q3 will join to Q7, Q3 will join to Q8. So this Q3 and Q8. So this Q3 and Q8 and Q7. Q3 will join to 7, Q3 will join to Q8. Then Q8 will join to 4, Q7 will join to 2. So this 2 and this 4. Join these points with the help of French curve like this. Similarly, 4 will join to 5, 2 will join to 6, so it is overlapping. 6 will join to 1, 5 will join to 1, it is overlapping. Okay, then finally, let's the longer edges, which one is visible and which one is invisible. So first I am taking this 3, so up to P3 it is visible, then invisible, then visible. Similarly 2, so 2 it is visible up to here, then invisible, then visible, and similarly 4 invisible, like this. So this is the problem. In the cylinder, square prism is penetrated, and one more thing is added in this problem, that is, if the intersection point is not obtained regularly, so you have to take an additional intersection points. Okay, so try this problem on your sketchbook. Finally give the dimensions and symbol and show me. Thank you.